What's up guys, welcome back to a new video. In this session, we'll be looking at how to solve matrix multiplication. We'll be solving several exercises step by step, where I explain everything I do along the way. As always, these exercises start out very basic, but will get progressively more complex towards the end. So feel free to skip around according to your own level. The timestamps can be found in the description below or the comments. Matrix multiplication. As you can see, I've written down the general formula for how to solve such a multiplication of any size of matrix. However, as is often the case with mathematics or science, instead of breaking our head over general formulas, we can get a much better understanding by doing exercises. And this is why in this video, we'll only be considering exercises and we'll leave this general formula as it is. So with that out of the way, let's go to the first exercise. The first exercise will be a warm-up. So we get 1, 0, 0, 1, the first matrix, and we multiply it by the matrix 3, 2, 1, 5. The first step to perform this matrix multiplication is to see whether we are even able to do it. And to do this, we identify the size of both matrices. So both matrices are 2 by 2 matrices, which means that this first number signifies the number of rows. So both matrices have 2 rows. And the second number signifies the number of columns. So both matrices indeed have 2 columns, which means that both matrices are 2 by 2 matrices. To identify whether we can even make this multiplication is to look at these inner numbers, and they have to be equal to be able to perform this multiplication. If they are not equal, then the multiplication of these two matrices is not defined. In this case it is, so we are able to do this multiplication. The second step is to look at what kind of matrix or what size of matrix will the result be. And to do this, we look at these two outer numbers. And we see that the resulting matrix will be a 2 times 2 matrix. And for a 2 times 2 matrix, we'll have to calculate 4 elements. And let's now do this and see how this matrix multiplication works in practice. We first determine the first element here on the first row and the first column of our resulting matrix. To do this, we'll be looking at the first row of the first matrix and the first column of the second matrix. And more specifically, we'll be multiplying these two numbers and adding the product of these two numbers. And then you'll get the following. So we get 1 times 3, so 1 times 3, plus 0 times 1, 0 times 1. And that's already the first element of our matrix multiplication. For the second element, let's take this one on the first row and the second column of our resulting matrix. For this, we'll look at the first row of our first matrix and the second column of our second matrix. And again, in the same fashion, we multiply these two numbers and we add the product of these two numbers. And we'll get the following. So we get 1 times 2, 1 times 2, and we add 0 times 5. So we add 0 times 5. And that's already the second element of our resulting matrix. The same can be done for this element on the second row and the first column of our resulting matrix. And therefore, we look at the second row and the first column. And in the same fashion, we multiply these two numbers and we add the product of these two numbers. And we get the following: 0 times 3, which is the multiplication of these two numbers. And we add 1 times 1, which is the multiplication of these two numbers. And now on to the last element, which is on the second row and the second column of our resulting matrix, which means that we'll be looking at the second row and the second column of our initial two matrices. In the same fashion, multiply these two numbers and add the product of these two numbers. And we'll get 0 times 2, that's these two numbers, plus 1 times 5, which is these two numbers. And at this point, the multiplication is already done, and we can just write this matrix out by, well, making these little sums. So we get 1 times 3 plus 0 times 1 is 3. For this element, we get 1 times 2 plus 0 times 5, which is 2. For this element, we get 0 times 3 plus 1, which is 1. And for the last element, we get 0 times 2 plus 5, which is of course equal to 5. And we have our resulting matrix. Now, in this specific case, it's interesting to notice that our resulting matrix and this matrix over here is actually the same one. And this is because, as you probably know, this matrix, the 1, 0, 0, 1 matrix, is actually the identity matrix. Now, what is the identity matrix? It replaces the 1 for normal numbers. Because for normal numbers, if we do 1 times any number, we just get this number again. Well, the same holds for this identity matrix. If we do the identity matrix times any matrix, we again get the same matrix. This went very smoothly, so let's go to the next exercise. In the next exercise, we'll be looking at 1, 1, 2, minus 1, multiplied by 9, 8, 7, and 6. Again, the first step is to identify the shapes of these matrices. So it's 2 times 2, and this is also a 2 times 2. We check whether we can do the matrix multiplication, so 2 and 2 on the inner sides, so we can indeed do the multiplication because they are equal. And what will be the resulting matrix? Well, it will be a 2 times 2 matrix again, because these outer two numbers are both 2. So let's now get into the procedure again by looking at the first element on the first row and the first column. To get this element again, we look at the first row of the first matrix and the first column of the second matrix in the same fashion that we multiply these two numbers and we add these two numbers, or the product of these two numbers, which gives us 1 times 9, 1 times 9, plus 1 times 7, 1 times 7. And that's already our first result. For this element on the first row and the second column, we look at the first row and the second column of our second matrix. And again, we multiply these two and we add the product of these two numbers. So we get 1 times 8, which are these two, plus 1 times 6, which are these two. Now onto this element on the second row and the first column. So we look at the second row of our first matrix and the first column of our second matrix. And again, we multiply these two and we add the product of these two numbers. And we get the following: 2 times 9, which are these two, plus minus 1 times 7, which is the minus 1 times the 7. And the last element of our resulting matrix on the second row and the second column will be obtained by looking at the second row and the second column. Again, we multiply these two numbers and we add the product of these two numbers. So we get 2 times 8 plus minus 1 times 6. So 2 times 8 plus minus 1 times 6. And our matrix multiplication is done. We only have to calculate these very simple sums, which is 9 plus 7, which is 16. For this element, we get 8 plus 6, which is 14. For this element, we have to take care of this minus sign. We shouldn't forget it. So we get 18 minus 7, which is of course 11. And then for the last element, we get 16 minus 6, which is of course 10. And we have our resulting matrix already. So on to the next exercise. And in this case, we're not going to look at square matrices. So we get the matrix 2 minus 2, and we multiply this by 1, 2. The first step, as always, is to identify the shapes of these matrices in order to look if we can even be able to make the multiplication. In the first case, we have one row and two columns, which means that this is a 1 times 2 matrix. In the second one, we have two rows and only one column, which means that we have a 2 times 1 matrix. So let's see whether we can do this multiplication. We have a 2 here and a 2 here, so the inner numbers here are equal, which means that we indeed can do this multiplication. So what will the size of the resulting matrix be? It will be a 1 times 1 matrix, so 1 times 1. But a 1 times 1 matrix, well, that's just a number, because it only has one row and one column, which means, well, it's only a number. So in the same fashion as before, to get this one number, we'll look at the first row and the first column, because this is actually at the place of the first row and the first column. But since we only have one row and one column, well, it's the only element. Again, we multiply these two numbers and we add the product of these two numbers. And in this case, this simply becomes 2 times 1 plus minus 2 times 2. And this simply becomes 2 minus 4 is minus 2. And we already have our result. And note that this is indeed a number. So a 1 times 1 matrix. Let's now go to the next exercise. And what we'll try to do here is what happens if we swap those two around. So what happens if we try to multiply 1, 2 with the matrix 2 and minus 2? So what is the result of this one? Well, as a first step, we identify the shapes of these matrices to see whether we can even make this multiplication. In this first matrix, we have 2 rows and 1 column, which means that we have a 2 times 1 matrix. In the second matrix, we have only 1 row and 2 columns. So this is a 1 times 2 matrix. So indeed, these inner numbers are equal, which means that we can do the multiplication. Now, what will be the size of the resulting matrix? Well, it will be a 2 times 2 matrix. So we see that from this already, that the result will not be the same, because here we had a 1 times 1 matrix, so a number, but here, in this case, we'll be getting a 2 times 2 matrix. So the result of swapping these two matrices out will be vastly different, which is something that we'll cover in one of the next exercises. So let's see what this becomes. We'll be getting a 2 times 2 matrix, which means 4 elements to determine, to calculate. The first element is on the first row and the first column. To calculate this element, we'll be looking at the first row of the first matrix and the first column of the second matrix. So this might seem odd at first because I only encircled 2 numbers, but that's quite simply the case because this matrix only has 1 column, so the first row will only be 1 number, and this matrix only has 1 row, so the first column will only be 1 number. So this makes it actually very simple, because what we need to do now is multiply this number with that number, and we're done already. So we get for this element 1 times 2. For the second element, on the first row and the second column, we look at the first row and the second column of the second matrix. And again here, we see that we only get 2 numbers, so we simply have to multiply 1 times minus 2. So this number times that number. The same is done for this element, so on the second row in the first column. So we look at the second row and the first column. So we simply get 2 times 2, which is of course 4. Then for the last element, on the second row and the second column, we look at the second row and the second column, which are again 2 numbers. And we get, of course, 2 times minus 2. And our result will be this simple sum. So we get 2 minus 2, 4, and minus 4. And this is our result, and it is indeed a 2 times 2 matrix. Let's go to the next exercise, which is 1 minus 1 multiplied by 1, 3, 5, 2, 4, 6. And again, the first step is to identify the shapes to see whether we can do this multiplication. So we have 1 times 2, 1 row and 2 columns. And for the other matrix, we have a 2 times 3 matrix because we have 2 rows and 3 columns. And we see, if we look at these inner numbers, that indeed we can do this multiplication. And if we look at the resulting size of the matrix, we get a 1 times 3 matrix, which means 1 row and 3 columns. So this will basically somehow look like this. Again, for the first number, the first element of our resulting matrix, it's on the first row and the only row and at the first column. So this means that we'll be looking at the first row and the first column. And in the same fashion that we multiply these two numbers and we add the multiplication of these two numbers. What we get is the following: 1 times 1 plus minus 1 times 2. For the second element on the first row and now the second column, we get the following, because we'll be looking at the first row and the second column. In the same way, we multiply these two numbers and we add the multiplication of these two numbers. And here we get the following. So we get 1 times 3 plus minus 1 times 4. 1 times 3 plus minus 1 times 4. And we get our result. Now I have to shift this last bracket a bit more to the right because I'll otherwise run out of space. For this last element, which is on the first row and the third column. So we look at the first row and the third column. And again, we multiply these two numbers and we add the multiplication of these two numbers. And we simply get 1 times 5 plus minus 1 times 6. And our matrix multiplication is done already. Now we only have to make these little sums. For this first element, we get 1 minus 2, which is simply minus 1. For the next element, we get 3 minus 4, which is minus 1 again. And for the last element, we get 5 minus 6, which is again minus 1. So the result of this multiplication is minus 1, minus 1, minus 1. Again, this is indeed a 1 times 3 matrix because we had a 1 here and a 3 here, so it checks out. Let's go to the next exercise where we have 9, 8, 7, 6 times 1, 1, 2, minus 1. And these are actually two matrices that we already saw. However, in the second exercise, the one that we already did, these two were swapped position. And now we will see that even if we have 2 times 2 matrices, swapping position in a multiplication will still yield another result. So because we already know that we have 2 by 2 matrices, we know that we can do the multiplication and that the resulting matrix will also be a 2 times 2 matrix. So we will have to determine 4 elements as we did before. The first element on the first row and the first column is of course the following. So it's the first row and the first column. And again, we multiply these numbers and add the product of these numbers. We get 9 times 1 plus 8 times 2. For this element on the first row and second column, we look at the first row and second column. And by now you'll know the drill. So we get 9 times 1 plus 8 times minus 1. For this element on the second row and first column, we'll be looking at the second row and first column. So we get 7 times 1 plus 6 times 2, which is 7 times 1 plus 6 times 2. And for the final element on the second row and second column, we'll be looking at the second row and second column. And we get the following result: 7 times 1 plus 6 times minus 1. And this is, of course, simply equal to 9 plus 8 is 17. 9 minus 8 is 1. Here we get 7 plus 12, which is 19. And for the final element, we get 7 minus 6, which is again 1. And this result is actually different, you can check of course, than the previous result that we got when we swapped those two out. So in a sense, in mathematical sense, matrix multiplication is not commutative. Let's go to the next exercise, which is 3, 1, 5, 2 times 2 minus 1 minus 5, 3. Again, we have here 2 times 2 matrices, so we already know by now that these can indeed be multiplied because these inner numbers are equal, and that the result will be a 2 times 2 matrix, which are these outer two numbers. So we'll have to determine or calculate 4 elements. Again, now a bit faster. This first element on the first row and first column will be obtained by looking at the first row and first column. So we get 3 times 2 plus 1 times minus 5. The element on the first row and second column is obtained by looking at the first row and second column, which becomes 3 times minus 1 plus 3 times 1. For this element on the second row and first column, we look at the second row and first column, and we simply get that 5 times 2 plus 2 times minus 5. For the last element on the second row and second column, we look at the second row and second column, and we of course get 5 times minus 1 plus 2 times 3. And the matrix multiplication is done. And we actually get a very interesting result here, because we get 6 minus 5, which is 1. Here we get 3 minus 3, which is 0. For this element, we get 10 minus 10, which is 0. And for the last element, we get minus 5 plus 6, which is 1. So what we get here is just the identity matrix. And this shows that this matrix is the inverse of this matrix. And in the same sense that 1 over A times A is equal to 1, we get that this matrix times this matrix is equal to the identity matrix. Let's now go to the final exercise, which is the following. So we get 1 minus 2, 3, 0, 1, 0, 8 minus 5, 1 half. And we want to multiply this matrix by the following matrix, 3, 0, 2. The first step is to identify the shapes of these matrices to see whether we can indeed do the multiplication. So in this case, the first matrix, we have a 3 times 3 matrix because we have 3 rows and we have 3 columns. And the second matrix is actually a 3 times 1 matrix because we have 3 rows and we only have 1 column. Looking whether we can do the multiplication, we look at these inner numbers and we see that they are indeed equal, so we can do the multiplication. And the resulting matrix will be a 3 times 1 matrix. So we will have to determine 3 elements in our matrix. The first element, which is on the first row and on the first column, because there's only 1 column, we'll get by looking at the first row and the first column. And also in this matrix, there's only 1 column. And again, we multiply these numbers, we add the multiplication of these numbers, and now here we add the multiplication of these numbers. And this then simply becomes 1 times 3 minus 2 times 0 plus 3 times 2. And we already have our first element. If we look at the second element, which is on the second row and first and only column, this can be obtained by looking at the second row and the first column. And again, we multiply these numbers, add the multiplication of these numbers, and add the multiplication of these numbers, and we get our result, which is 0 times 3 plus 1 times 0 plus 0 times 2. And for the last element on the third row and first column, we look at the third row and first column. And again, for one last time, we multiply these numbers, we add it by the product of these numbers, and then we add the product of these two numbers. And we get 8 times 3 minus 5 times 0 plus 2 times 1/2. And our result will be the following. So we get 3 minus 0 plus 6. So we get 9. Here we get 0 plus 0 plus 0, which is 0. And our final element is 8 times 3 is 24. Minus 0 plus 1 is 25. And we have our final result, which is indeed a 3 times 1 matrix. We have 3 rows and only 1 column. This brings us to the end of this video about matrix multiplication. I really hope you learned something, and as always, if something is not clear or you're confused by anything, just let me know in the comments below. I will read all of them and reply to all of them. If you have any suggestions for future topics, also leave a comment below. I will most certainly make a video on that specific topic. And as always, if you learned something, leave a like. If you want to get notified by future videos, subscribe. And with that, I see you guys in the next one. Bye.